Okay, so in this lesson we're going to talk about single replacement and double replacement, okay? And so we're going to need some materials for this, and it's in your notes, so we'll talk about this. You will get these materials on the test, so be able to refer back to them. In some ways, single replacement is a lot easier because you don't necessarily have to predict exactly, because you can just check the activity series. So the way that we will recognize a single replacement is it's always going to have an element and a compound, okay, on both sides, okay? And so all we'll have to do is check the activity series to see if one element will replace another one. So let's look at the activity series, okay? So you have this in your notes. Also, you will get a separate copy of this, or you should, so that you don't have to keep flipping back to your notes. But the way the activity series works, if you look at this arrow over here, is it is... oops, sorry, it went on the... Oh, sorry, I hate that when it does that. It's my bad. So if you notice right here, the arrow, it means the most reactive is at the top and the least reactive is at the bottom. So if I look at this list of metals, that means lithium is the most reactive metal, okay? It means it can replace anything that comes below it. So lithium can replace everything on this list, okay? And if you look down here at the bottom at gold, it is the least reactive, meaning it can't replace anything that comes above it, okay? So let's look at calcium right here. I want to know, will calcium replace, say, iron? And I see calcium's here, and I see iron's right here. And so, yes, it could, all right? But iron could not replace calcium in a compound because calcium is more reactive, okay? Same thing over here with the nonmetals. Fluorine is the most reactive, so it can replace everything, but iodine can't replace anything, okay? And so we'll do a couple of examples so you can kind of see how this works. But what I want to make sure that you understand is that metals will only replace other metals, okay? And then nonmetals will only replace other nonmetals, because you still have to put a positive and a negative thing together. So metals will only replace metals, nonmetals will only replace nonmetals, with one exception, and that is right here, hydrogen, okay? If you see that right there. Because we can react things with water and acids, okay, then some metals can actually replace the hydrogen and kick it out, okay? For our purposes, don't worry about this stuff right here. If it's above hydrogen, we're going to say it replaces it. That was more for pre-AP, so don't worry about all of this stuff right here. Just kind of mark it out and ignore it. You just want to know if it's above hydrogen, then it will replace it. So here we go with a couple of examples. So in these examples, we're going to look at what's by itself. Okay, you're going to look at what's by itself and see, will it replace the metal, because these are all going to be metal examples here. So we want to know, will lithium replace potassium? Okay, so please look at your activity series. Well, I just told you a while ago, lithium's at the top, so lithium will replace everything. So what it does is it kicks out potassium, and it takes its place. So now I will join up lithium and chloride. They will be together, and you've got to write the formulas correctly. All right, lithium's a +1, chloride's a -1, so they go together. So you got to write them correctly, and then it kicks out potassium by itself. And then you go back and see if it needs to be balanced. In this case, it is not. Everything was 1-to-1 ratio, so it's good. Okay? In the case of the second one, we need to know, will tin replace hydrogen? So we go look at our activity series, and we see tin, SN, is not on the list. Am I missing it? Okay, somehow, oh yes it is, I'm sorry, I missed it. It's right between nickel and lead, I'm sorry. So if you see tin, it is above hydrogen, so it will replace it. So it kicks out hydrogen and it takes its place. All right, so we're gonna go with tin plus 2 is Cl2, okay? And then if you notice when it kicks out hydrogen, it's gonna bubble out of solution as a gas, okay? So hydrogen by itself is going to be H2 because it's a Brinkelhoff. And now I need to go back and balance it. Easiest thing to do is put a 2 right here and it's balanced. Now, 10 is one of those things that can form a +2 or a +4, okay? So if you showed that either way, if you showed it as 10 + 4 and you did SnCl4, that would still, I would consider that to be correct as well, okay? So now let's do the next one. Now I want to know, will 10 replace zinc? And I look at the list and I see that no, it will not, because 10 is below zinc. Make sure you're looking at this list with me. 10 is below zinc, and so it will not replace it. So we would say that this is a no reaction. It would not happen. All right, and you are perfectly welcome to abbreviate NR for no reaction. Now I want to look at nickel, and I want to see, will nickel replace water, the hydrogen in water, okay? And because I told you to ignore that stuff to the side, we're going to say it does. Now, if we were in pre-AP, we'd say, it doesn't react with water, but I don't want y'all to have to worry about that. I want you to just say nickel's above hydrogen, so it would happen, okay? So we would, what happens is it joins up with the hydroxide, so we get nickel hydroxide plus hydrogen gas. Okay, I see that I have 2 oxygen right here and 4 hydrogen, so to balance that, I would put a 2 right there. All right, now let's do some examples from your left side activities. All right, oh no, I'm sorry, we have to do the non-metal examples. I forgot about those. So now what we're going to do is we're going to check our non-metals. We're going to go to the other side of that activity series, and we want to see, will chlorine replace bromine? And so I go look at the list, and chlorine is above bromine, so it is going to take bromine's place. So now I would get sodium chloride, and it kicks bromine out, kicks it to the curb. Bromine is one of our diatomics, so we have to write it as Br2. And now I need to balance, and I see that I have 2 chlorines on one side and only 1, so I put a 2 right there. And now I have 2 bromines on the product side and only 1, so I need to put a 2 there. So now it's balanced. Excuse me. All right, let's check out the one below it, fluorine. We want to know, will fluorine replace bromine? And it will, because fluorine's at the top. So we would get magnesium is a +2. Fluorine's a -1, so I need 2. It kicks out bromine now by itself, and I get Br2. And if I look at that, I see that it's already balanced. Iodine, we check to see if it will replace bromine. It will not, because it's below it, so we say no reaction. Next one is bromine. Will it replace chlorine? I look at my list. Bromine is below chlorine, so it will not work, so that is also a no reaction. All right, some of our examples, okay? So I have silver nitrate, which I would write as AgNO3 plus nickel. So I want to see if the metal will replace the metal. I look for nickel. It is above silver, so it does happen. So I would get nickel nitrate, which is normally a +2. And then I would go silver out here. Okay? I'm going to treat that nitrate as all one thing. I have 2 of them on this side. I only have 1 on the reactant side, so I'm going to put a 2 there. And then that will force me to put a 2 there. Sodium bromide, NaBr plus I2. These are non-metals, so I want to know, will iodine replace bromine? And it will not, so this is going to be a no reaction. Last example, magnesium plus nitric acid. It came from 8, so it's coming from nitrate, so it's HNO3. And I want to know, this is an acid, so I want to know, will magnesium replace hydrogen? And it absolutely will. So I'm going to get magnesium nitrate. Magnesium is MgNO3 I'll need 2 of them since magnesium is a +2. And then it kicks hydrogen out, so it's going to be H2. And so in order to balance that, only thing I need to do is put a 2 right there, because now I have 2 hydrogen and 2 nitrates. So on the next slide, we'll talk about some examples from the lab, because there was a couple of single replacement from the lab. So let's talk about those. First single replacement that we talked about was the demo that I did, where we put the zinc in the hydrochloric acid. Okay, so we had zinc plus HCl. And obviously we know that reaction happened because we saw bubbles. Okay, we saw bubbles. So you'll need to predict what that made. But that's an element in a compound, so it's single replacement. Also, we added the aluminum to the copper 2 chloride. That's where we put the aluminum full in that blue stuff. And something happened with that. And so you need to predict that. And then we also did a single replacement that did not happen. Nothing happened. It was a no reaction. And so you put something in, I think you put the copper in the sodium chloride solution, and nothing happened. So we would call that a no reaction, and we visibly saw that nothing happened with that one. Okay? So I think that, oh, there was one other single replacement that I'm going to actually have you find and predict, but there was one more single replacement. Okay? Okay, double replacement are a little bit different. Remember, we're going to recognize double replacement by the fact that you're going to have 2 compounds on both sides. 2 compounds on both sides. So these are a lot of rules for double replacement, okay? You're going to have to check your solubility rules, which are on the paper with your description of what a double replacement is. I am not going to read through all these rules word for word, but I want to read some of the highlights. So first thing you're going to do is predict the products that it's going to make, and I'll show you how to do that in a second. Once you predict the products, you're going to have to check your solubility rules, okay? If it's soluble, that means it stays dissolved in water, okay? That's what aqueous means, AQ. So if it's soluble, you're going to write AQ behind the product, AQ, okay? If it is insoluble, that means it does not stay dissolved. That means it will form a solid. So if you see the word insoluble, or if you find out your product is insoluble, okay, you write S behind it for solid, okay, for solid. Also, if a gas forms, or a liquid forms, like forms liquid water, or any pure substance form, these reactions will happen, okay? If we're doing a reaction and we predict the products and everything stays aqueous, meaning it stays dissolved in water, then we're actually going to say it's a no reaction, okay? And the reason being is because they all stays dissolved, nothing forms. So ionic compounds, when they dissolve in water, they actually split apart and they're no longer an ionic compound, they're dissolved in water. So let's look at a couple of examples. Okay? So the way you're going to read this solubility chart is you're going to read it like this. This top part, all of these things are soluble unless they are with one of these exceptions over here. So you'll notice that group 1 metals and ammonium, all your nitrates and acetates are no exceptions. So they're going to always be soluble. So they're always going to be AQ. When you have anything joined with that, you're always going to write AQ afterwards. Okay? If you have chlorides, bromides, or iodides, you would write AQ unless it's with one of these, silver, mercury, or lead. Then you would write an S behind it, because if it joins up with one of those things, it's going to make a solid. Okay? Same thing for sulfates, chlorides, and all those. It's okay. Now, if you look at the bottom, these are always going to be insoluble. So you would write the S behind them unless they're with one of these exceptions over here. So if they're with one of these over here, you're going to write AQ behind them. And you'll notice that many of these exceptions are group 1 metals and ammonium and these things that are always soluble. Okay? So let's do some examples so you can get the hang of this. Okay? So first thing is when you're doing a double replacement, the easiest thing to do is we're going to do outside, inside. And what I mean by that is the two outside things are going to now join up, and the two inside things are now going to join up. Okay? So we still have to write the formulas based on their charges. Okay? So if I were to write sodium and oxygen together, sodium is a +1, oxygen's a -2. So I would write Na2O. Now I want to put magnesium and chloride together. Magnesium's a +2, chloride's normally a -1. So that would go together, MgCl2. Now I go look at my solubility rules, okay? And I go to the very first one on there. Says group 1 metals are always soluble. Sodium is a group 1 metal. So up behind this, I would say this is aqueous, meaning it stays dissolved in water, it does not form, okay? Then I go look at magnesium chloride, and I see I have chlorides right here, and I go look at my chlorides, and I see always soluble unless it's with silver, mercury, or lead. Well, it's not with one of those things, so this would stay AQ. So this would actually be a no reaction. Nothing would happen. I would just be mixing two liquids together and no changes would happen. Okay? Let's do the next example. Okay? Outside, inside things together. So here we go. So I'm going to put, and it doesn't matter which one you write first, okay? So I could have written, I'm going to actually do the other ones first. This time I'm going to put potassium, outside things together. Or this time I'll put the inside things together first, so you'll see that it doesn't matter. So I have sodium and I have permanganate. So each one of those are a +1, okay? So I would say sodium, MnO4, okay? Now I'll put my outside things together, and I've got potassium oxalate. Okay? So potassium is a +1, oxalate's a -2, so it would be K2C2O4. And now I go check my solubility rules, and I see I have two group 1 metals, always soluble, so it's going to be aqueous plus aqueous. So this would be another example of a no reaction. Okay? Now, I want to show you an example of one that actually happens, okay? So I'm going to do silver nitrate plus KCl. So I do outside, inside, and I get silver chloride, and I get potassium nitrate. And now I go check my solubility rules. Potassium is a group 1 metal. I know it's going to stay aqueous. So I'm going to put that right away. Start recognizing that group 1 metals always stay aqueous. But if I go look at chlorides, I see that chlorides are soluble unless they're with silver, mercury, or lead. Well, obviously I have silver here, so this one would stay solid. So this reaction happens. So if I needed to balance it, I would go ahead and balance it, okay? On those previous two, they were no reaction, so I didn't bother to balance them because the reaction doesn't happen. So there's no reason to balance it if it doesn't happen. So only go back and balance it if the reaction happens. Okay? And I know this video is getting kind of long, but I kind of need to finish it, so I'm sorry this video is so long. The good news is you're watching it in class, not at home. So let's do number 2 on our left side activities. So we're going to do silver nitrate. Oh, goodness. I get so mad at myself when I do that. So we're going to do silver nitrate plus potassium phosphate. So I'm going to have K3PO4. And if you're still struggling with writing formulas, I suggest you go back and review those lessons from Chapter 7 because this is going to be important throughout this. So I'm going to do outside, inside together. Again, it doesn't matter if you want to do outsides together first or insides together first. It does not matter. I'm going to do KNO3 first, just because I can do that. They're both 1 to 1. And then I'm going to do silver and phosphate. Silver is a +1, phosphate's a -3, so I'm going to get Ag3PO4. And I go look at my solubility rules. Potassium's a group 1 metal, always soluble. Nitrate's also always soluble, so that's definitely going to be an AQ, meaning it does not form. Okay? silver phosphate, I go look up phosphates and I find phosphates and I say, oh, they are insoluble unless they're with one of those exceptions. Okay? And so because they're not with one of those exceptions, they are insoluble, so that's going to be a solid. Okay? Now, I am going to balance that now because I have 3 silver. I need to put a 3 right here. I have 3 potassium right here, so if I put a 3 right here, it takes care of it. Okay? All right, this next one is calcium acetate. Okay, it's Ca, C2H3, O2, and I need 2 of them, plus sodium carbonate. Okay, and so you might be able to get to the point where if you look at these, before you even go predict them, I can look at that sodium is a group 1 metal. So no matter what I put it with, it's going to be aqueous. Okay. Acetate, if I go look at that, it's always soluble, okay? And so whatever it goes with is going to be aqueous. So I can look at this very quickly and go, hey, you know what? It's going to be a no reaction, okay? And then the last one, excuse me, is calcium hydroxide that we're going to do, plus phosphoric acid. Now, this one's going to be a little tricky because this is an acid and a base. Okay, bases are hydroxides. Okay, so you're still going to do the outside inside. Oops. Okay, so I'm going to get calcium phosphate. Okay, and then I'm going to get water. Okay, anytime I get an acid and a base, I'm going to get water. Okay, but it is going to be liquid water because it is a pure substance. Remember, aqueous means to be dissolved in water. I can't dissolve water in water. So it's actually going to make liquid water. So anytime you see an acid and a base, that reaction will happen. Also so happens that phosphate is also going to be a solid when you look at its solubility. Okay, so I am going to need to balance that. I see that I'm going to need 2 phosphates because of this right here, so I put that there. I see that I need 3 calciums because of this calcium right here. So now if I add up my total hydrogen, I see that I have 3 times 2 is 6, plus 3 times 2 is 6, so I have 12. So I'm going to put a 6 right there. Okay? I'm going to put a 6 right there. So that's balanced now. All right? Now, examples from the lab. There was only one example from the lab, okay? And it was the very last one, part 5, okay? Oops, sorry about that. Part 5. So you will need to do that and predict what happens because you definitely saw that something happened. Okay, again, I'm sorry about the lesson, and if you hear that door knocking, that's somebody in 7th period knocking while I'm trying to finish the lesson. All right, hope to see you soon, guys. Bye.